Okay, folks, as we get going on week two here, as I promised, I would put together a quick video to show some of the core competencies, actually all the core competencies you need in Excel to complete the homework from chapters 3, 4, and 5, which we're covering in week two. So the problem, so let me start by saying I think most of these problems involve the data set that we used last week from the Lincolnville School District bus data. I think the questions this week, I don't think any of them asked about age. So I'm going to use this data just to demonstrate the things that you're going to have to do this week, primarily, as I recall, for chapters 3 and 4. There's a little bit for 5 that I'll talk about here at the end. But let's just talk about really kind of the descriptive statistics things that you will be doing this week. So the first thing I think we want to do is we want to build a histogram. Now, we did that in some regard last week when we looked at the bar chart. Now we could have, extended the width of the bars so they all matched up or touched each other. In that way, we had some, one solid density photo. But there's another way to do that in Excel that's actually quite handy. So let me start by just highlighting all the data here. Again, there's 80 data points. Then if you go to the insert menu, and in the middle of this toolbar, this palette up here, is all the charts that Excel will build for you. And right here in the middle, you have something that actually looks like a histogram, and it's some statistical charts. We'll actually use a couple things out of here this week. So if you click on the histogram, it's kind of like magic as compared to what we did last week. This will give you the histogram. Remember, we had 80 data points, and using the rule of base 2, that required 7 classes. This one has 1, 2, 3, 4, 5, 6, but that's an easy fix here. If you just put your cursor down here on this horizontal axis, any one of these bin ranges, and just double click your mouse, you'll get an option over here to address the bins. And I think simply this week, I think all we need to do is we click on the number of bins and change that from 6 to 7. Watch when I hit the enter key here. Watch, you'll see the presentation of the chart change, and then we obviously have seven distinct classes. So that is one thing that you'll need to do this week, and then you'll need to do some interpretation for whatever variable it is that you need. So let me get rid of that. The other thing, you want to be able to compute mean, the arithmetic average, the mean, and the standard deviation. So to do this, again, let's scroll in the data. Make sure that when you do this, that you only get the numerical values, that you do not get the age tag. So I'm just going to scroll here and get everything. And then let me just go back up here. Actually, sorry about that. So let me say average. This will compute the arithmetic mean. Then you have to, you have to scroll the data after you type in the function. And then if you, go back up here and you close the parenthesis, you will get the, this is what we would refer to now as the mean. We don't want to call it the arithmetic average or average. The proper term in statistics is the mean. So the mean is about 6.98 years. Now, to compute the standard deviation, let's see, let's just use STD-DEV for standard deviation. In Excel, again, we talked about these functions that are inherent to Excel, and there are 2 types of standard deviation that you could compute. One based on a statistic, which would be the sample standard deviation, and one based on a population, which would be a parameter that's based on a population. I think for this week, let's just assume that this is sample data. So if you type equals, remember that's what you type, number 1 for Excel to compute anything. And then if you want any of these great functions that are already built in, the function that you need to compute the sample standard deviation is STDEV. And once you start typing, you'll get a list of all the functions that are available. And we're going to assume that this is a sample. So .s is the sample standard deviation. And then we'll just, again, scroll in all the values. Just put your mouse in that top numeric value and pull everything down. Then close the parenthesis. Let me show you how you did that. So C2 to C81 is the range of values. Just close the parenthesis. and there is the sample standard deviation. The other thing that you're going to have to do in the problem in Chapter 3 is you're going to have to apply the empirical rule. Now, the empirical rule is discussed in Chapter 3, and it tells us if a variable is distributed in a certain way, it will tell us how much of the distribution percentage-wise is within a certain number of standard deviations from the mean. And sometimes the empirical rule is referred to as the 68, 95, 99 rule. And that is because 68% of the population in a distribution that is empirically distributed, 68% of the distribution is between plus and minus 1 standard deviation. 95% is between plus or minus 2 standard deviations, and 99% of the distribution, or 99.7 or 99.8, depending on what book you read, will be within 3 standard deviations. So as you look at, there's a question in Chapter 3 that said, by what or within what range will I find 95% of the distribution? So remember, that would be 2 standard deviations. So this is effectively 1 standard deviation. So it would be 2 standard deviations either side of the mean, and that would bound or establish the bounds for which you would find 95% of the distribution. So I think that covers what you're going to do in Chapter 3. Chapter 4, let's see. I think that's pretty much. Let me do a couple things here. I think number one, we need to look at what a box plot is, and a box plot is just another way to look at quantitative data or visually. And obviously there's the histogram, but there's a box plot. Let me start by again scrolling in all the data here. Here's all the data, and then we will go up here to insert, and we're going to go back to all our statistical charts, and then in there is a box plot. And let me there's a good explanation in the book. Let me talk about what's here. First of all, I want to do just one thing here. I want to find the minimum and the maximum values here. Actually, let me just do this. The minimum value is going to be, the minimum value is 1, and the maximum value equals the maximum value here. All right, so this is good. Remember what you get in a box plot, what this is actually showing you. What it's showing you is, so let's start in the middle. Now, what you have to be careful of here is this box plot is based really more on, I would say, percentiles than it is anything else. So once you find this middle box and you find the line here in the middle, this represents the median. Again, that value which is right in the middle of the data set. And it does also, for the heck of it, it does show you the mean, 6.9, whatever. And I think we had 6. I don't know why that's different, unless I missed a data point. But this should show you the mean of the distribution. Now, as we go backwards from here, so if this is the mean, remember this is the first quartile. And what does that mean? It means 25% of the distribution is below this point and 75% above. And we'll get to the, and sometimes this is called the first quartile. This line here shows you the range of the first 25% of the distribution, with 1 being the minimum value. So let me kind of go backwards here, and then I'll go back towards the top. So the minimum value is 1. The 25th percentile, or the first quartile, looks to be 5. The median looks to be about 7. And then here is, and let me also say that this median is also the second quartile, because 50% of the distribution is below this value and 50% of the distribution is above this value. So one more time, first quartile, second quartile. The third quartile separates the bottom 75% from the upper 25%, and that looks to be about 9. And you can obviously look at these values in the distribution if you like. And then finally, what this is saying is the remainder of the distribution, this last 25% of the distribution, ranges from 9 to a maximum of 14. And so that's the interpretation of the box plot and what it all contains. Now, I'm going to add another crazy value in here. I'm going to add a value of, let's say, 25 to make a point here. So let me get rid of this and let me redo the box plot. So I'm going to go highlight all my data once again, and I will go back up and I'll insert. And if I go to the box plot, here is the box plot. Let me spread this out just a little bit. Now, I think everybody understands why I added 25. If you see, so again, here is the basic box plot that we had before. And remember, what this value is going to show you is the last data point before the box plot thinks there's potentially an outlier. And in the discussion of box plots, it will tell you at which range above the 75th percentile and below the 25th percentile at which you would find values that would be considered outliers. And it has to do with what's called the interquartile range, which is the value of the third quartile minus the value of the first quartile. So 1.5 quartile, or 1.5 times the interquartile range, I'll throw you that, on each side below the 25th percentile and above the 75th percentile. Anything above that range or below this range will tell you where you have a potential outlier. So certainly you want to be careful of that this week as you go through the discussion. Let's see, the only other thing, I think the only other thing that is necessary to say here, when you get to chapter 5, you are going to start getting into questions related to probability. And remember, probability, we have a discussion post right off the bat this week that tells us, if the probability of some event is 0, we know that that's an impossibility, and that the probability of something or some event being 1 means it's an absolute and it's going to happen. And then everything else, the probability of any event is always going to be between 0 and 1 inclusive. When you start getting into computing probabilities for this problem in chapter 5, you're going to be doing it based on a fractional relationship, so a numerator and a denominator. And the only thing I think that I will point out to you here is that when you do the problem in chapter 5, problem 94, make sure you read the questions carefully, because depending on how the questions read, it will dictate the value in the denominator. And I think, again, we're still using that Lincolnville School District bus data. So we know that the total number of observations, the maximum that you should see in any of the denominators will be 80, but not all questions on problem 5 or in chapter 5, problem 94 relate to the entire set or total 80 cases. So just be very careful of that and you should be fine. And like I said when I did my video solution for chapter 1, if there is any question about how to do anything in Excel, that should not be the limiting factor for us. We can talk openly and freely about how we would use Excel to do some of this computational stuff. The premium for you all is understanding what it is you're seeing and being able to convey results. So let's not let Excel be the limiting factor, and please don't hesitate to reach out if you have any questions. So have a great week, and I hope this is helpful as you get going in chapter 2.